Hey everybody, this is Harbin and we're at the last video notes of the semester. So let's produce some products. Remember to read chapters 6 and 7. So before you can predict products, you have to know what reaction it is. So make sure if it's combination, you know it because it has two elements. Decomp has one reactant. Single replacement has one element and one compound. But be careful with this one because if the element is oxygen and the compound has carbon and hydrogen in it, then it is not single replacement, it is combustion. All right, and double replacement is two compounds. Joke break. Okay, so if you find out the reaction synthesis, which is also combination, you need to cancel the charge and make the compound. So it's always going to be a metal and a non-metal, so you just cancel the charge and make the compound. If you know the reaction is decomposition, that means it's one reactant, then break it up into its products. If you know the reaction is combustion because it's got a hydrocarbon plus O2, you just write down water and carbon dioxide, states of matter and balance. Okay, so let's look at these one. Calcium reacts with oxygen. Well, I know calcium is a metal. Oxygen is a diatomic gas. Look, it's two elements. So what do? I look on the periodic table and I find out calcium's a +2 and oxygen's a -2. So I do CaO because it's +2 -2. And that means the charges go away, charges cancel. So there we go. And then I say to myself, self, I wrote its correct identity, and I put in the states of matter, and now I balance it. Let's see, a 2 there and a 2 there. Done. Okay. Next reaction, nitrogen dioxide decomposes. I know nitrogen dioxide is NO2. Decomposing means it breaks down into its elements. So I'll put N and O, and then I'll say to myself, self, what are these 7 elements that are diatomic, and N and O are 2 of those. So I have to put 2's next to them when they're in their elemental state. Okay, and then now that I have the correct identity, then I have to put in coefficients. Let's see, I'm going to need to put a 2 here, and then a 2 there. Boom, done. Okay, this is one compound, so I know it's going to break down into its elements. So I write the elements, and then I think, are any of these diatomic? Well, here's the... All right, and so then I'll need to, it's already balanced with coefficients, yay. Okay, next reaction, Zn plus O2. It looks like an element in an element. Yes, it is. All right, so then I put the elements together to make a compound, but I have to cancel their charge. So I know Zn's a +2 and O is a -2, so it's a 1-to-1 combination. So charge goes away, so I have the correct identity, and then after that, I go back and say, that's going to be a solid, it's going to be a gas, that's solid, right, and 1 zinc, 1 O, 2 O's, 2 zincs. All right, C2H4 burns. Looks like combustion. So C2H4 plus O2 is going to give me CO2 plus H2O. Always the same, always the same. And so then I put the states of matter in. These are both gases. Gas. I have to tell you this is a gas, but I will do that. And so I have 2 carbons, 4 hydrogens, 4 hydrogens. And now I have 4, 5, 6 oxygens. So I put a 3 there, and it is done. Okay, so that's how you do it. Recognize and then write the correct identity of the products, then put in states and balance. Okay, here are 4 more for you to try. All right. Those are the ones that are sort of easy and straightforward, and then the single and double replacement are a little more difficult. So a single replacement, once you recognize, you have to check the activity series to see if it works, okay? And then you write the compound and the element, the new ones, if it works, and let's see if we can do it. I know this is single replacement because there's an element and a compound. So then I see if the element is higher than the one in the compound. Yay, potassium's higher than sodium. So I know it's going to work. So I know sodium's going to get kicked out. See ya. And then I have to put potassium and chlorine together. So I look at the periodic table. I find out potassium's +1, chlorine -1. So it's going to be KCl. Right? And let's look at the next one. tin and aluminum bromide. I know it's single replacement because we have element in a compound. So look for the element is tin. And then the one in the compound's aluminum. Not going to happen. No reaction. Lii and Br2. So this is the element and the compound. So now the element Br is on this list. It's a nonmetal. And it's higher up than iodine. So this is going to work. So I have to put that Li with the Br. And it's going to be LiBr because it's a +1 and -1. So once I cancel those out, get the correct identity, I know iodine gets kicked out, so that's I2. Then I have to go back and put coefficients. I'm going to need 2 there and 2 there, done. Okay, so this is chlorine, this is fluorine, this is the element, this is the compound. So I check to see if the element chlorine is higher than fluorine. No reaction. Okay. All right, double replacement is 2 compounds forming. It's going to do one of these 3 things, and usually we're looking for a precipitate, but a gas or water could also form. Okay, so precipitate means insoluble. And so what's a precipitate? It's a solid that forms when 2 solutions combine because those ions find each other and make a solid. So here's how you use Coulomb's law to do it. You multiply the charges, and if you get a big number, 4 or greater, that's going to be the precipitate, less than 4. There's some heavy metal halides and hydroxides that are exceptions. So I'm also going to show you the solubility rules, which you have on the back of your pink sheet. Okay, so like things to look for, AgBr. So it says here that bromides are insoluble, or soluble unless they're with silver. So this is going to be a solid. All right. KNO3, potassium nitrate. Nitrates are soluble. Potassium compounds are soluble. So this is going to be aqueous. All right. You can practice with all of these and then check them with me. All right. So what does aqueous really mean? For ionic compounds, aqueous means ions get surrounded by water. Surrounded by water. And so they can move around. So water tears the ions away from the crystals. So that's if they're that's if they're aqueous, right? So when NaCl goes into water, you're really going to get Na surrounded by water, Na ions, and chloride ions surrounded by water. So if this was a sodium ion, you can see water surrounding it, and now those ions can move, and that's why that conducts electricity when it's dissolved. If aqueous is for a covalent compound, this is ionic, right? That's what we just saw. This is covalent. So covalent compounds are these whole molecules, right? And the whole molecules are attracted to each other by intermolecular forces. So what water does is it has 2 ends. So water's 2 ends can surround the molecules and dissolve them. But notice the molecule stays the whole thing. Stays whole. That's very different than ionic. So for covalent compounds, whole molecules get surrounded by water. So they don't break up into smaller pieces of a molecule. They just get the whole molecule turns aqueous, right? So for ionic, each ion gets surrounded by water, so it splits into smaller pieces with charge. But covalent, just each big piece of the molecule gets surrounded by water. Okay. So when we talk about dissolving, there's differences. So this is ionic, and so it's going to dissolve into ions, right? This is covalent, so it's going to dissolve into each tiny piece getting surrounded by water. Each whole molecule gets surrounded by water. This is ionic, so it's going to dissolve into all of its ions, phosphates and sodium. Right. So that gives you a better idea of what happens when things are in water. Okay, so let's see if we can figure out what reaction this is. Sodium chloride reacts with lead nitrate. So sodium chloride is Na+1 Cl. All right, it's aqueous. Reacts with lead 4 nitrate +4 -1. So we have Pb NO3, 4. That's aqueous. All right, so we have a double replacement. So we predict the products by doing the switcheroo. So we're going to get lead's going to be, or sodium's going to be first. It's going to go with nitrate, and it's NaNO3. And then this is all in one line, but I ran out of room. And then lead's going to go with chloride. Lead's a +4, chloride's a -1. So we're going to have PbCl4. Now out of these two, which one's going to be solid, which one's going to be aqueous? Well, this one's going to be aqueous. And that's going to be solid because of Coulomb's law, +4 minus 1 is going to equal 4. That's going to equal -1 total. And then we balance it. So I've got 4 nitrates. So I need 4 nitrates. Now I need 4 sodiums. So 4 sodiums, 4 sodiums, 4 chlorides, 4 chlorides, 1 lead, 4 nitrates. Yay, it's balanced. Okay. Go ahead and try this one. And so it's +2, this is -2, so it's CuSO4. And it's a compound. It's got to be aqueous over here. Barium +2, fluoride -1, BaF2. That's going to be aqueous. All right, double replacement, switcheroo. So barium's got to go with sulfate. We'll keep copper first. Copper's first. It's got to go with fluoride, so +2, -2, +2. Well, -1, but we need 2 of them. And barium and sulfate. Barium's a +2, sulfate's a -2, so we have BaSO. And this is going to be the solid because it's a +2 and a -2 equals 4. Absolute value, solid, Coulomb's law. So that means this is aqueous. And then, and only then, after you get their identities, do you put in their coefficients. So let's see, 2 fluorines, 2 and 1 barium, 1 sulfate, 1 copper, 1 copper. Woohoo! All the coefficients are 1s. Okay. Now, states of matter, stating your success. We have solid, liquid, gas, and then aqueous, which is in a state of matter, but it's something that you'll see in chemical equations. Okay. Metals are solids, except mercury, Hg is a liquid. Okay, so know that. Diatomics, all of them are gases, except bromine's a liquid and iodine's a solid. So remember, Noff, cool, breathe. Okay, so we got gas, 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 liquid, solid. Okay, ionic compounds are solids in decomp and combination. Right? Ionic compounds are aqueous as reactants in double and single replacement. But you have to check the solubility rules in Coulomb's law to predict whether the products are aqueous or solid in double replacement. And combustion gives gases. So this is your one slide to memorize your states of matter. Okay? Know this. Stating your success. Write this down. Write it. Write it. Know it. Know it. Okay. Let's see. You can predict the products for all of these. So what you should do first is 1, predict products. So that means identity, tell what they are with the right formula. 2, put in the states of matter, balance with coefficients last. That's the last thing you should do. So this is an element and an element, so they're going to make a compound. Na on the periodic table is +1, Cl is -1. Okay, we're done with that. So let's put in the states. That's an ionic compound. That's going to be solid. That's a gas. That's a solid. Use the slide before to help. Okay. Now let's do the balancing last. Put a 2 there. Put a 2 there, and I'm done. Woohoo, woohoo. Okay. Let's go to this one. Element compound. But wait, this element is oxygen. That compound is C's and H's. So you could just write CO2 and H2O automatically, and we know they're gases. This is a gas, and I'm telling you this is a gas. You wouldn't know that one. I'd have to tell you. Very last, put in coefficients. So I got carbon, carbon, woo, hydrogen, 2. All right, and I have 2, 3, 4, 2, done. Woohoo! All right, there's more to do. Let's do this one. One single thing is decomposition. So I got some nitrogen, I got some hydrogen, I got some oxygen. And then I check for diatomics, and they're all diatomic. Okay. And so the last thing I could do, I'll put in states, gas, gas, it's gas, it's a gas. This is an ionic compound, so it's solid. All right, now let's see. We need 1, 2, 3, 4 H's. So put a 2 there. 2 nitrogen, 2 nitrogen, 3 oxygen, 6. All right, let's see what we got going on now. 4, 2. I'm going to need a 2 here, a 2 there. All right, so that's going to make that a 2. It's going to bump this up to 4 for 8. Okay. All right, there's more here. You try. You try. And you try. You try. All right. So, to review, recognize your reactions. Then write the identities of the products. Remember their identities first. Correctly do them. If it's a single replacement, look at the activity series. If it's a double replacement, use Coulomb's law to figure out the solid. Combustion is always the same. Know your diatomics and know what aqueous means. And then you are all set. All right. Peace out.